All right. All right, today we're going to continue on with classes and take an example that we had from last quarter where I had you create a record of inventory. Remember, we had a hash that contained a unique ID that pointed to an array. Remember? Because a hash only has the concept of a key and a value. So in order to get 3 pieces of data into this structure, we had to put the rest of the stuff in an array. So I had a shirt followed by the price of the shirt, right, $19.99. So there's 3 data pieces, and we kind of squeezed it into this hash. This is really not the best data structure for this, but the point of this assignment back then was to work with hashes, not and understand the difference between hashes and arrays. So this more betterly, how do we say that? This works better in a class because a class can have any number of attributes associated with it. And when we think of this, what is this? This is, in the real world, this would be one row of a database, maybe, right? One record, one item in our inventory. So we might call our class item, all right? Item with a capital I, and that's our class. And what types of data then are we going to have in our class? 2 ints and a string, okay? 2 integers and a string. So it would be a float, probably a little better. Yeah, get technical with you. So to start with, let's pass the information in. We'll call it the ID, and the description, and the price. All right. So when we create a new item, that's the data that we would pass into our class. And in the background, when we get to Rails, for instance, the background processing of this is going to store that in a database. So that's going to be a row of our database containing our items. We might have an item table, and it's going to have this type of information in it. So when we create a new item, this is exactly what we're going to do. We're going to pass some information into it. So I want you to write the next pieces of code that's going to save this data into variables that persist in the class. Now, what do we call those? Instance variables, okay? So take these and store them in instance variables, and I'll wait. All right, so really this is just a matter of having 3 assignment statements. So I'm going to call them the same as what's being passed in because it's a good variable name. So my instance variable ID, I'm going to assign to the value that gets passed in. My instance variable description is going to have description. And my instance variable price is going to have my price. So that's it. All right? So if I were to create a new item, I already wrote this down here. The shirt is going to be what type of object? This variable shirt here. No. It's an item object, right? It's an item object because it was created from the item class. It's not a string. It contains strings and integers and all kinds of other stuff and methods, but it's an item object, all right? So if I create that, and then let's just say puts shirt.inspect, just see what I get out. If I run, and I got to run the right program. Then I get out the representation of what it is. Remember the class it came from and a memory location or ID of where it is. And then my 3 instance variables that I have. So I can see that the data is actually getting stuffed into those instance variables. All right? So the next thing that we might want to do is have a nice way of printing this information out. Right? We need a way for the item to print itself. And remember that every time I wanted you to print out an item, I wanted a complete record, right? I wanted the ID and the description and the price all tabbed out nicely and looking good, right? So let's create the method called 2s. And if without that method, let's undo that for a second. If I just print out shirt.2s, I get a shortened version of the inspect. It's not very useful. There is a method called 2s, and it's given to me by the hierarchy of these classes higher up. And I can change the way that 2s works by defining my own version of this 2s, and that's called overriding the method. It's called an override. So I'm going to return, remember, we don't do any putses in our classes. I'm going to return a representation of this record. So I'm going to have the ID, and I'm going to pass the instance variable of the ID. Let's have some tabs in here, and then the instance variable of my description. And then a tab, and then the instance variable of my price. All right? So now when I call the 2s method, it's going to return this string based on whatever this object is. Remember that the method applies to the object before it, to the left of the period. So the shirt is calling its 2s method, which is defined here. So let's run it. Look at that. Isn't that nice? Prints out a nice record. If I have another object, we'll call it, pants. And it's going to have an ID of something else. Pants. And its price is going to be $49.99. And if I print out the pants, it's going to have a different object, but it prints it in a nice little order here. Isn't that cool? So my object here now not only has the data associated with it, but it knows how to print itself. It knows how to do some things to itself. Yes, sir?
I was going to ask you if Newline would work, because I tried the backslash did.
Yep.
And it wouldn't return it, just print out the backslash did.
Remember that the backslashes only work if you're in double quotes.
I did that.
So if I have a /n here, this seems like a bug with the puts that, remember, we had last quarter. I'd have to put 2 /n's in here to actually get it to double space it. That was a problem, and I consider that a bug with Ruby. That just is wrong.
Okay.
Well, maybe if we updated our program.
No, I don't think so. No, that's a Ruby issue, not a Ruby mine issue. All right, so our class is growing a little bit. We've got a nice way to have our structure in place. But remember that the ID that we had was a self-generated ID. Remember that the program itself generated a 3-digit unique random number to associate with the new data that you had. Remember that? So I want to create, instead of passing in the ID, instead of the user figuring out what the ID is, I want the class to figure that out for me. Okay, I want it to figure out the ID itself. So I want to modify this and not pass in this data here. All right, I want it to be able to do that for me. So I'm not going to receive the ID, and consequently this is now wrong, and I'm going to let the class create its own unique ID, and I can put any code I want inside of this class. So how did we create a random 3-digit number? Rand of 100 using the range 999. All right. So I let the class create that. Every time the initialize happens, which is only when you do an item.new, it's going to create the ID for you. So let's see if this works. Look at that. I've got 730 and 710. Isn't that sweet? It did it for me. Run it again. I could. Yeah, I haven't fixed the problem with, and I'm not sure we'll get to that today. That takes another level to do that. But every time I run this, I get different IDs because I'm creating a new object. I'm starting the program from scratch again, right? It creates a new object. And in fact, this is the way databases work. When I create a new row in the database assigns, typically, if you define your table correctly, an auto increment ID that's unique, right? So every time I create a new record, it creates the ID for me. So I've kind of created a little mini database here that does that randomness for me. Isn't that cool? All right, any questions on that? Now, we'll work out the uniqueness later. That's going to require a class variable to figure that out. That's a whole different topic. All right, so I said earlier that we want to have an array. Let's say that my record might have different sizes associated with it. Now, this is kind of a contrived example, but let's say I want to have an array of sizes. So how would I create that when I create my new record? Okay, I might create an @size. That's an instance variable. And let's say I want to store this inside of my class as an array structure. So I just create an empty array. All right, so now my size is initialized every time I create my new item. Right? So let's, this won't change anything because I'm not utilizing that size yet. But if I were to print out the inspection of this instead, well, the problem is my 2s overrides that. So I'm going to change this so I can get at the data. I actually see the size here as an array. And, well, nothing. There's nothing in there. So it is actually being stored with the object. So let's take that out. And how would I print out, add all of the sizes that are in my array inside of this? Okay, good. So I might add the value of, and I'm going to put it on its own line just because it'll fit better. I want to add the size, and that's an array. So I want to convert that into something that's nice and readable. How would I do that? How do I convert an array to a string? A nice way to do that. I could do a loop, right? But there's a method in the array. Remember, this is, what type of data is this now? It's an array. It's not a string. So I can do array type stuff with it. And there's a join method that lets me create a string with a separator in it. So I might have a string of a comma with a space after it. Okay, so that's going to join all of the values in my array and put them out here. So I might add the word sizes with a colon, and then it's going to print all the sizes as I do that. So when I print this, I have the sizes, and I have nothing because I never put anything into my array, right? There's nothing in my sizes array. Everybody with me so far? All right. So now, in order to get data into my size, this comes with what we talked about, encapsulation. I don't want the outside world to know how I'm storing this information. I could use a hash here. I could use anything I want. And so they don't need to know that I'm storing it as an array. So I need to add methods that let the user of the class, which is this main program, you have to put yourself in the shoes of the main program utilizing this class. I want to have some methods that let me add and delete data from my size array. but the outside world doesn't need to know that it's an array. So let's add a method. We'll call it add size. And we want to pass in some information like the size, right? And for now, let's think of the sizes as just a string, a bunch of strings. All right, so how would I add this string to my size array? I just push it into the array, right? So I take my at size and I push in the size. All right? So there you go. I wrote your assignment for you. Isn't that nice? So, yeah, I just give you an A right now. So what I can do now is to call this method on the object that I want to add a size to. So for the shirt, before I print it out, let's say I want to call shirt dot, and lo and behold, RubyMine knows already I have a new method. So I say add size, and I want to pass in a string representing maybe a large shirt. All right. So now this large string gets passed into my add size method, which then gets pushed into my instance variable array here and gets stored with that object. So this object now has different data than the pants object, right? They're different objects, different items created from my item blueprint. Remember, coming off the assembly line, they have the same concept, they have the same methods, but they have the different data associated with it. So let's run this guy. So now my shirt has some sizes associated with it. Isn't that cool? All right, so let's do that. Let's add another one. Shirt.add size, and we'll call it a small. All right, and then run this again. And now I've got a large and a small. Remember, because I'm joining it with a comma and a space, that it puts a nice representation here.
What's the default?
The default is just a space. If I just say join, it just put, it used to put a space from what I remember. It just smashes it together. So you'd have to put a space, but I want a comma. All right? You can put semicolon. You do whatever you want, however you want to represent this. All right? And my pants would work the same way. I can call the pants.add size method and call them x large. And when I run this, now I have an extra large pair of pants. And so the data is now being stored inside of this array. And the outside world, notice I don't have anywhere in here do I know that there's an array inside of this shirt. I shouldn't care. There's nothing about that I have to worry about. I just need to know that they have methods that I can utilize to operate on this little object that I created. So we could do the same thing and take remove the size, okay? So we're running out of time here. But let's write a remove size. And we want to pass in which size they want to remove, right? We need to know what they want to do with that. Now, how do I take away an element from an array? All right, so I say at size dot delete, and I pass in the size, all right? So that will search through the array and delete the element from the array, right? So let's go and remove. We'll call our remove method remove size, and we'll remove the large size. I like spaces here, so remove the large size. We'll run this. And so it printed it out. Oh, what happened? I didn't print it again. That's what I was going to do. So I'm going to add a large and a small size. I'm going to print it. Then I'm going to remove the large size, and I'm going to see what happened. All right, so it removed the large, and now I only have a small size. So I can manipulate my little inventory item here by utilizing these methods that I've written for myself. All right, and it makes my class now really compact. It's very portable. It keeps all the code associated with this item in one place, and my coding is a lot cleaner with classes like this. All right, any questions on any of this? Isn't that fun? That's some fun stuff, man, I'm telling you. All right, that's enough for today then. We're out of time.